Hello students, namaste. So welcome back to my channel. Myself is Harsha and Kumar. In this video we are going to learn a topic called as structural elucidation of glucose. What is this structural elucidation of glucose? See here, very simple thing. See, right now we don't know the structure of glucose. Okay, there are specific reactions, okay, which explains what are the things or what are the functional group or how many carbon atoms are there will be present in the structure of a glucose. Okay, we should learn everything. This topic is very important and it is very simple. Okay, aram se we can learn it. Okay, so first point. So why we should know this one? See, this is like, it's like giving the proof. Okay, in the structure of glucose, this functional group is there. So everything, this will give the proof. Okay, that is the thing. So from the elemental analysis, and also from the molecular weight determination, so they have got the molecular formula of glucose will be what? C6H12O6. From the elemental analysis and molecular weight determination, they have determined the molecular formula of glucose, that is C6H12O6. So they got it. This is the first point. Okay, so let me this is the first structural elucidation of glucose. Okay, the second structural elucidation of glucose. Okay, reaction with, okay, very simple, reaction with HI. So reaction with HI or called HI. So what will happen now here? If I take glucose, okay, so if I take glucose, for this glucose, if I add hydrogen iodide, okay, very simple. So I am going to heat this one. So this glucose in the presence of hydrogen iodide, it is going to give one product, that is N-hexane. Hexane means what? 6 moles. 6 number of carbon atoms. It is singly bonded. Hexane. So CH3, CH2, 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 CH2. So 1, 2, 3, 4, 5. CH3. Okay. So glucose, when it is treated with hydrogen iodide, okay, it will give a product called as what? N-hexane. N-hexane. And also it is going to give one more product along this one. CH3 bond CH2 bond CH2 bond CH 1 2 3 4 CH2 bond CH2 bond CH3. So 1 2 3 4 5 6. So here I am going to take iodide. What is this? If I do the number system, how many carbon atoms are there here? 1 2 3 4 5 6. So 6. Single bond is there. Hexane. But in the second position, what is there? Iodo group is attached. So this compound name is called as what? 2-iodo. 2-iodo-hexane. 2-iodo-hexane. Okay. When glucose is treated with hydrogen iodide, it will give N-hexane and also 2-iodo-hexane. Because of this product is formed. Hexane means 6 carbon atoms are there. Right? 6 carbon atoms are there. So it is clear that this glucose contains what? How many carbon atoms? 6 carbon atoms. This is in a straight chain. This is the aliphatic straight chain. This is not a cyclic. Okay. So it is very clear that this glucose contains what? 6 carbon atoms. Very simple. Okay. Please note down. From the elemental analysis and the molecular weight determination, it will be C6H12O6 and also what? Glucose, it contains what? 6 carbon atoms. Clear? So let me write here. The first one will be what? C6H12O6. The second, we have determined that the glucose contains what? 6 carbon atoms. 6 carbon atoms. Okay. Next one. The third one. The third structural elucidation. Okay. Reaction with hydroxyl amine. Reaction with hydroxyl amine and also hydrogen cyanide, HCN. Okay, I am going to erase this one. Okay, hope you have copied. So, before going this point, I am going to write a basic structure of glucose. So, CHO bond CHOH 4 times bond CH2OH. Okay, this is very important. Okay, this is the basic structure. So 4 carbon atoms, 5 and 6. So 4 carbon atoms, 5, 6. Okay, very simple thing here. So reaction with hydroxyl amine and HCl. So hydroxyl amine means what? NH2OH. NH2OH. Okay, so what happens now? When glucose is treated with hydroxyl amine, what is the product we are going to get it here? Okay, so let me write the structure here. CHO bond CHOH 4 times bond CH2OH. When this is treated with NH2OH. NH2OH. Okay, so very simple. Dehydration will take place here. H2O. So what is the product we are going to get here? That is very simple. This carbon atom already contains hydrogen. So CH bond CHOH 4 times bond CH2OH. Clear? So in the place of oxygen, actually here C double bond OH will be there. So in the place of double bond O, double bond N is going to come. So double bond N bond, this nitrogen is all bonded to what? OH group. So bond OH. So we are going to get this product. This product name is nothing but glucose oxime. Glucose oxime. So this is the reaction of glucose with respect to what? I mean, when it is treated with hydroxylamine. If this is treated with HCN, the same glucose is treated with what? HCN. So what is the product we are going to get here? So CHO, right? So C double bond OH, right? So here one double bond oxygen will be converted into what? Single bond oxygen, and this one will abstract hydrogen. This OH will come. Okay, so here CN is going to attack and remaining same thing. CHOH 4 times bond CH2OH. Okay, so hope you got it here. This hydrogen is going to attack oxygen. I mean oxygen, it is going to abstract the hydrogen. So what is this compound name called as? So this is glucose cyanohydrin. Glucose cyanohydrin. This compound name is called as what? Glucose cyanohydrin. Okay. So this complete reaction with hydroxylamine or reaction with HCl, you are going to learn in the aldehydes, ketones and carboxylic acid chapter. Okay, so we are going to get the same product here when if there is a presence of what? Presence of what? Carbonyl group. Presence of what? Carbonyl group. So from this reaction, it is very clear that glucose contains a carbonyl group. So this is the third point. So third point what? A glucose contain what? Carbonyl group. So carbonyl group. Okay. So this, the same reactions you will come under in the aldehydes, ketones and carboxylic acid, but in the place of glucose some other aldehyde will be present. Okay. So hope this is very clear to you. Okay. So when glucose is treated with hydroxylamine, we are going to get glucose oxide. When glucose is reacted with HCl, we are going to get glucose cyanohydride. So this product confirms that the presence of what? Carbonyl group. So carbonyl group is there. So then we are having two options now. One, it should be a aldehyde group. One, it should be a ketone group. So how we are going to check whether glucose contains aldehyde group or a ketone group? So we are going to just confirm it in the next one. So hope you have copied this one. I am going to start with the fourth point. So this is the third point. Okay, the presence of what? Carbonyl group. Okay. Yeah. So the fourth point will be a what? We need to check whether it is a aldehyde group or a ketone, whether it is a aldehyde group or it is a ketone group. Okay. So oxidation is the process. Oxidation is the process. Okay. Oxidation. So here I am going to use mild oxidizing agent. Oxidizing agent. And also I am going to use a strong oxidizing agent. So which is the mild oxidizing agent I am going to use here? That is bromine water. Bromine water is a mild oxidizing agent. Or okay, what about the strong oxidizing agent? I am going to use here concentrated HNO3, concentrated nitric acid. So here in the case of mild oxidizing agent, listen carefully here. Here CHO is there. Okay, this CHO will be converted into COOH. Okay, so CHO will be converted into what? COOH. So CHO will be converted into what? COOH. Okay, but if I use a very strong oxidizing agent, it is going to oxidize CHO and also CH2OH. So here what is the conversion factor here? So it is going to convert CHO into what? COOH and also CH2OH and also it is going to convert into what? COOH. Very simple. Clear? This is called as gluconic acid and this is called as saccharic acid or glucaric acid. Okay, let's check the reaction. I'm going to take the glucose structure here. So this is the glucose structure. So CHO bond CHOH bond CH2OH 4 times. When this glucose okay is treated with what? Bromine water, Br2 water. Okay, so what is going to happen here? The CHO will be converted into what? COOH. Aldehyde group will be converted into what? Carboxylic acid group. So what is going to happen now here? COOH, CHO will be converted into COOH. The remaining will be remain same. So CHOH 4 times bond CH2OH. This compound name is called as what? Gluconic acid. Gluconic acid. Okay, the same glucose, if it is treated with concentrated nitric acid, okay, HNO3. So what is going to happen now? The CHO will be converted into what? COOH. Okay. So, and also CH2OH will be also converted as what? COOH. CH2OH is also converted as COOH. So here CHOH 4 times bond CH2OH in the presence of strong oxidizing agent, it is also converted as COOH. So this is also called, this product is called as glucaric acid or saccharic acid. Glucaric acid. Very simple thing. So here, when aldehyde or any substance, if I add mild oxidizing agent, if it is converted into a carboxylic acid, then this indicates the presence of what? Aldehyde group. So these reactions will confirm what? It contains what? Aldehyde group. So this is very, very important. And also this aldehyde always shows positive response to the tolerance test or tolerance reagent and also Felling's reagent. Okay, if I add tolerance reagent to the glucose, since it contains aldehyde group, the tolerance, this compound reduces the tolerance reagent and form a silver mirror. Okay, for the same glucose, if I add Felling's reagent, okay, since it is presence of aldehyde group, so we will get red color PPT. Okay, so tolerance also we can adopt this one, and also Felling's. So this reaction is very, very important. So this is the, and this is the fourth point. Okay, fourth structural elucidation of a glucose. So fourth point confirms that this reaction, from this reaction, that aldehyde group is there. So it contains what? Aldehyde group is there. Aldehyde group is there. Okay, so let's go for the fifth topic of the structural elucidation of glucose. Okay, copy. The next one, the fifth point will be, okay, reaction with acetic anhydride. Fifth point will be what? Reaction with acetic anhydride. Reaction with acetic anhydride. Okay. Children, this chapter is very, very easy. Okay, one thing, you should learn the concepts very clearly, because they may ask you in your final exam, okay, what happens when glucose reacts with concentrated HNO3 or bromine water. You should aware about the structure of a product. Okay, that is very important. Okay, acetic anhydride. So acetic anhydride, a formula will be CH3 C double bond O bond C double bond O bond CH3. This is acetic anhydride. This can be also written as CH3 bond C double bond O 2 times. Clear? This can be also written as what? CH3 bond C double bond O 2 times bond O will be there. Okay, so usually if there is a OH group, okay, so let me write CH3 bond OH. Okay, so what is going to happen here? Here breakage of bond. So here breakage of bond. So OH minus, this is O minus, this is going to combine now. Okay, what is the product we are going to get here? CH3 bond O bond C double bond O bond CH3, and also this is one more product here, CH3 bond C double bond O OH. Okay, so here one ester will be there, one here carboxylic acid product will be there for. So this is a basic reaction. So what happens when acetic anhydride reacts with glucose? Okay, listen carefully here. OH will go out. Okay, if there is a OH only, it is going to form one acid now. Clear? So what happens when acetic anhydride reacts with glucose? So this is the formula, CHO bond CHOH 4 times bond CH2OH CH2OH. This is a glucose, correct? Then glucose is treated with acetic anhydride. So CH3 bond C double bond O bond C double bond O bond CH3. Okay, so we are going to get a product called as glucose pentaacetate. Glucose pentaacetate. How the structure is going to form here? Here there is no OH group. This is the aldehyde group. So we are not going to get the substitution of this acetate group is not going to attack here. So here OH group is there. So what is the product? CHO bond C bond O bond C double bond O bond CH3. Okay. So how many times here? 4 times. So here CH2 bond O bond C double bond O bond CH3. Why here also it has been attacked means because here also OH group is there. So that is the reason. Okay. So that is the reason it is going to form like this. So I am not going to put CH. This children, this is CH. Okay. So this is how many times? This is 4 times. Okay, if it is not clear, let me write once again. CH. CH. Clear? So this is 4 times. So this product is called as glucose pentaacetate. Glucose pentaacetate. Okay. And also it forms one more byproduct, that is will be CH3COOH. How many substitution here? 4 plus 1, 5 substitution. So 5 carboxylic acid is going to form here. So it is very clear that if there is a OH group, so we are going to get this kind of product or one more acetate product here. So how many we got it now? Pentaacetate. So this product confirms that there are 5 OH groups are present. What is OH group? Hydroxyl group. So this is the 5th one. Reaction with acetic anhydride confirms that it contains, glucose contains what? 5 OH group will be there. So this is also very important reaction. So many times they are asked in the final exams also. Okay, what happens when glucose is treated with acetic anhydride? So we are going to write this product. Copy this one. Very simple. Nothing is there. OH group. So almost we are done. Now we should check this OH group, the 5 OH group, whether a 2 or 3 OH group are present in the same carbon atom or a different carbon atom. So it is very clear that the 6th point, okay, note. It is very clear that the 6th point, this glucose is highly stable. 6th point, a glucose is highly stable and there is no hydration or dehydration. Okay, whatever. Note down. Okay, I have rubbed the reactant also. Okay. Since I am doing online sessions here, that's the reason I am just giving some time here. Okay, so this is highly stable and no dehydration, not hydration, sorry. So no dehydration. So what do you mean? Loss of water, OH. See what will happen if a carbon contains OH group. Okay, if 2 or 3 OH group, anything is fine. So let me take, if there is a 3 OH group here, so this substance will undergo dehydration. Dehydration is what? The loss of water molecules. So H2O, aram se it will go. If the same scenario, if the OH group, the 2 OH group is attached to the same carbon atom, okay, this is just an example. This is just an example, okay. So what will happen? The dehydration will take place. Since the glucose is highly stable and also there is no dehydration takes place, it is very clear that the 5 OH group, are present in different carbon atoms. The 5 OH group are present in different carbon atoms. 6th point, the OH group present in different carbon atoms. I mean, it is very simple. No 2 OH group is present in the same carbon atom. So this is the important 6 points you should learn it. From all these points, the Fischer, his name is called as what? Fischer. He has given the structure of what? Glucose. He has given the structure of glucose. So the Fischer structure of glucose will be what? So there are 6 carbon atoms. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. It is very clear that aldehyde group will be there. Correct? Aldehyde group will be there. There are 6 carbon atoms. 1, 2, 3, 4, 5, 6. 6 carbon atoms. Okay. So CHO. And also at the last carbon atom CH2OH will be there. So just write it CH2OH. Now actually starts here. So 1, 2, 3, 4, 5, 6. I mean sorry, I'm just counting. Okay. So bond. Okay. Aldehyde is there means what? Carbonyl group will be there. So carbonyl group will be there. Okay. So remaining is OH group and different. Very simple here. Just learn a simple trick for glucose formula will be 1011. What is that? 1011. So 1 indicates hydrogen, 0 indicates OH group. 1 indicates hydrogen, 0 indicates OH group. So what is the formula now for the glucose? 1011. So this will applicable to the left hand side. So 1011. 1 0 means what? OH. 1 0 1 1. That's it. Very simple. If hydrogen is here, so here OH group will come. If OH group is there, hydrogen will come. H is there, OH will come. So H is there, OH group is there. So what is the different thing here? So this is carbon 1. So carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So in the third carbon atom, the position of OH group will differ compared to the second carbon atom, fourth carbon atom, fifth carbon atom. See, if you clearly notice that there are 5 OH group. 1, 2, 3, 4, 5. These 5 OH group are there. So this structural solution is correct, and all the OH group are attached to the different carbon atoms. So we have done, if we count the number of carbon atoms, and if we count the number of hydrogen, and if we count the number of oxygen atom, the molecular formula of glucose will be C6H12O6. So this is the structural elucidation of glucose, and this is the open chain structure of glucose. And also we should give preference whether this is a D sugar or L sugar. D sugar and L sugar I have explained in my previous video. Please check it out. So we need to check which carbon we should check, whether it is a D sugar or a L sugar. Very simple thing here. So this is aldehyde group. Priority will be there. This is one aldehyde group. So here CH2OH is there. So aldehyde and alcohol group. So preference will be given to the aldehyde group. So which is a less priority. OH group will be the less priority. So next carbon, which is the less preference here, aldehyde and alcohol group. So next carbon, we need to check whether it is a D sugar or L sugar. Okay. So if we clearly observe that, if we observe this one, OH group, it is on the right side. So then if OH group it is in the right hand side, means it is a what? D sugar. So it is a D glucose. This is also called as what? D glucose. This is overall structural elucidation of glucose. Okay. So hope you have understood each and every concepts. Okay, you should learn thoroughly with all the 6 points. Especially reactions. Okay, what is the product we are going to get? Okay, this is a very, very beautiful chapter and a very simple chapter. So please make sure that chemistry is a very, very easy subject, because I used to get feedback from the, feedback means usually I will be asking our students, sir, always we feel chemistry is tough. So once they completely involve and they have set at their mind that chemistry is easy, all the subjects will be easy. Okay, thank you.